Note 6.5b, simplify radicals. Recall the rational exponents property from your law of exponents. The nth root of a to the nth power is a to the m over n power. To get rid of a square, you take the square root. The square root of x squared is x to the 2 over 2 power, which is 1, so that equals x. If there's nothing right here, you assume there's a 2. When taking the square root of a number, you'll need to put a plus minus in front of it. For example, if you have the equation x squared equals 16, square root each side, and then on the side with the number, you're going to put a plus or minus sign in front. The square root of 16 is 4, so x equals plus or minus 4. So the solution set is -4 and +4. Here are some perfect squares that you need to remember when simplifying radicals. The square root of -1 is I, the square root of 4 is 2, square root of 9 is 3, square root of 25 is 5, and the square root of 49 is 7. You'll use these properties to simplify the square roots in the following examples. Example 1. Find the square root of each number. A. The square root of -36. -36 is the same thing as -1 times 36, which would be I and 6. So we'd have 6i right here. On B, we have the square root of -64. The square root of 64 is 8, and the square root of -1 is I, so we have 8i. And then on C, we have the square root of -81, which would be 9i. 9 times 9 is 81, and I times I is -1. Example 2. Simplify. You want to simplify the square root of 18. To do that, we want to break apart 18 into as many of these numbers as we can. -1, 4, 9, 25, and 49. There's no negatives here, so we can skip that one. 4. 18 divided by 4 is a decimal, so we can skip that. 18 divided by 9 is an integer. So we can break apart 18 into 9 times 2. 9 times 2 is 18. The square root of 9 is 3. The square root of 2 can't be reduced. So your simplified square root is 3 radical 2. Okay, let's do B, square root of 28. There's no negative, so we don't need that one. We can take out a 4. 4 times 7 is 28. We can't take out anything else, so we're done with that. So we have the square root of 4 times the square root of 7. The square root of 4 is 2. The square root of 7 can't be reduced. So your simplified radical is 2 square root 7. Let's do C, square root of -54. It has a negative, so we can rewrite it as -1 times 54. If we use our calculator and divide 54 divided by 4, we get decimal, so we're not going to use 4, and we're going to go to 9. 54 divided by 9, that's 6. So we can rewrite this as -1 times 9 times 6. 6 can't be reduced, so we rewrite as the square root of -1 times the square root of 9 times the square root of 6. We have I, 3, and square root 6. So our simplified expression is 3i square root 6. Let's do D. Square root of -90. We have a negative, so let's break it into -1 times 90. Okay, let's see if 4 goes into it. 90 divided by 4. That's a decimal, so we're going to skip 4 and go to 9. 90 divided by 9 is 10. So we can break that apart as -1 times 9 times 10. 10 can't be reduced. There's no perfect squares besides 1 in it. So we'll rewrite these. And then we have I, 3, and square root 10. So our simplified expression is 3I square root 10. Let's do the next one. E, the square root of 384. So there's no negative, so we can skip that one and try 4. 384 divided by 4 is 96, so we can do that. So we have 4 times 96. Let's see if we can divide on another 4. We can. So we have 4 times 4 times 24. And 24 divided by 4 is 6. So we write 4 times 4 times 4 times 6. Six can't be reduced anymore, so we'll go ahead and rewrite each of these square roots by themselves. So square root of 4 is 2, square root of 4 is 2, square root of 4 is 2, and square root of 6 is just the square root of 6. 2 times 2 is 4, 4 times 2 is 8, so your simplified expression is 8 radical 6. F is the square root of negative 180. It has a negative, so let's rewrite this as -1 times 180. Let's see if 4 goes into 180. 180 divided by 4, we get 45, so that works. So -1 times 4 times 45. Okay, if you divide 45 by 4, you get a decimal, so let's go on to the next number, 9. 45 divided by 9, that gives you 5. So we have -1 times 4 times 9 times 5. 5 can't be reduced anymore, so let's go ahead and evaluate each of these perfect squares. So we have I times 2 times 3 times the square root of 5. 2 times 3 is 6, so your simplified expression is 6I square root 5. For G, the square root of x to the 7th power, we're going to refer back to this rational exponents property. So we'll rewrite the square root of x to the 7th as x to the 7 over 2 power. To see what goes on the inside of the radical and what goes on the outside, we're going to do long division and find our remainder. 2 goes into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. You have a remainder of 1. So that means that we're going to have x on the outside with an exponent of 3 and an x on the inside with an exponent of 1. The quotient goes on the outside and the remainder goes on the inside. On H, we have the square root of x to the 9th power. So the square root of x to the 9th power is x to the 9 over 2. Do long division. 2 goes to the 9 4 times. 4 times 2 is 8. 9 minus 8 is 1. So your remainder is 1. So we have x to the 4th power on the outside and the square root x to the 1st power on the inside of the square root. For I and j, you have both a variable and a number. So it's going to be like two separate things. We will first reduce the square root of 20, and we will reduce the the square root of x to the 7th. Now 20 doesn't have a negative, but we can't pull out a 4. So 20 is the same thing as 4 times 5. The square root of 4 times the square root of 5. That's 2 square root 5. X to the 7th, or square root of x to the 7th is the same thing as x to the 7 halves. Do long division. You have a remainder of 1, a quotient of 3. So we have x to the 3rd, square root of x to the 1st. And then you'll put these together. 2 times x cubed times the square root of 5 times x. So that would be 2x cubed times the square root of 5x. And let's do j. Square root of 216x to the 8th power. Separate your number and your variable expressions. 216. Let's see if we can divide out of 4. We can. So we have 4 times 54. 54 is 9 times 6. So we have 4 times 9 times 6. Square root 4 times square root 9 times square root 6. That's 2 times 3 times square root 6. X, the square root of x to the 8th power is the same thing as x to the 8 over 2. 8 divided by 2 is going to be 4 with a remainder of 0. So you can rewrite that as x to the 4th power. Square root of x to 0 is just 1, so you don't have to write that part. So we'll put it all together. 2 times 3 is 6. 6x to the 4th power times the square root of 6. And that is your reduced expression. Example 3. Solve by taking square roots. We have x squared equals 18. So we'll take the square root of each side and put plus or minus in front of the 18. So x equals plus or minus the square of 18. But we can reduce this square root. 18 is the same thing as 9 times 2. So square root of 9 times square root of 2, so it'd be 3 radical 2. So x equals plus or minus 3 square root 2. So we have negative 3 square root 2 or positive 3 square root 2. You could also rewrite it as plus or minus 3 square root 2. Either of those would work. B. X squared equals 28. Take the square root of each side, put a plus or minus in front of the number side, and we have x equals plus or minus the square root of 28. We know 28 is the same thing as 4 times 7. Square root of 4 times the square root of 7. So we have 2 square root of 7. So x equals plus or minus 2 square root 7. C. Parentheses x minus 1 squared equals 121. What you want to do is take the square root of each side, put plus or minus. The square root and the squared cancel. You have x minus 1 equals plus or minus 11. From here, you're going to add 1 to each side. So we have x equals two different equations. 1 minus 11 or x equals 1 plus 11. So we have negative 10 and 12. So x equals negative 10 and 12. Notice since there's something on the inside of the parentheses, the two solutions are not just the opposite signs of each other. It'll be the same thing for D. We have parentheses x plus 7 squared equals 169. Take the square root of each side, put plus or minus. The square and the square root cancel. So you have x plus 7 equals plus or minus 13. It's another perfect square. Subtract 7 from each side. So there you have your two equations, x equals negative 7 minus 13, or x equals negative 7 plus 13. So we have negative 20 and 6. So our two solutions are negative 20 and 6. E, 3x squared equals 36. So on this one, we would divide each side by 3 first to isolate the squared part. X squared equals 12. Take the square root of each side, put plus or minus. X equals plus or minus the square root of 12. That's not a perfect square, so we need to see if we can simplify it. 12 is the same thing as 4 times 3. So square root of 4 is 2. Square root of 3 can't be reduced. So here's your two solutions. X equals plus or minus 2 square root 3. F, 2x squared equals 20. Divide by 2, and then we have x squared equals 10. Take the square root of each side, put plus or minus in front of the number part. X equals plus or minus square root 10. The square root of 10 is the same thing as we have 2 times 5, and neither of those are perfect squares, but they're prime. So those are your two solutions. X equals plus or minus 10. G, x squared plus 6 equals 60. The first thing you want to do is subtract 6 from each side to isolate the squared part. And then we have x squared equals 54. Take the square root of each side, put plus or minus sign. X equals plus or minus square root of 54. 54 is the same thing as 9 times 6. The square root of 9 is 3. Square root of 6 is just square root of 6. So those are your two solutions. H, x squared minus 7 equals negative 97. Add 7 to each side to isolate the squared part. X squared equals negative 90. Take the square root of each side, plus or minus. X equals plus or minus. Negative 90 is the same thing as the square root of negative 1 times the square root of 9 times the square root of 10. You can find that from example 2D as well on this page. So we have plus or minus 3i square root 10. So quadratic equations always have two solutions. They either will have two unique real solutions, one repeated real solution, or two imaginary solutions. Example 4. Simplify the expressions. A, 3 square root of 50 plus 8 square root of 8 minus square root 2. So the first thing we would do is not combine them because they don't have the same square roots, at least not yet. So the first thing we would do is simplify those square roots. A square root of 50 is the same thing as 25 times 2. 25 is, square root of 25 is 5, and then we have square root 2. Now for square root of 8, we can rewrite that as 4 times 2. Square root of 4 is 2. Square root of 2 is just square root of 2. So we're going to replace the square root of 50 with 5 square root of 2, and we're going to replace the square root of 8 with 2 square root of 2. So we have 3 parentheses 5 square root of 2 plus 8 parentheses 2 square root of 2 minus 1 square root of 2. We have 1 there because there's no number visible. So distribute and then combine like terms. So we have 15 square root 2 plus 16 square root 2 minus 1 square root 2. So this would be 30 square root 2. That's your simplified expression. B, 16 times square root 28 minus 9 square root 27 plus square root 7. Okay, let's simplify square root 28. That'd be 2 square root 7. Let's simplify the square root of 27, which would be 3 square root 3. Okay, and then replace those with the original. So you have 16 times 2 square root 7 minus 9, parentheses, 3 square root 3 plus 1 square root 7. Okay, 16 times 2 is 32. 27 square root 3 plus 1 square root 7. Now, since we have a square root of 3 here, and these have square root 7s, these are not like terms. So your simplified expression would be 33 square root 7 minus 27 square root 3. So this simplified expression will have 2 terms instead of 1 since they're not like. Alright, let's do C. This is a difference of squares where these are conjugates. So we're going to do the box method and find the area of the 4 boxes. So we have x minus square root 7 on the side and x plus square root 7 on the top. X times x is x, which is x's second power. X times square root 7 is plus x square root 7. X times negative square root 7 is a minus x square root 7. And then negative square root 7 times positive square root 7 is going to be a negative 7. These two will cancel, and so you're left with x squared minus 7. So A was x squared is just x squared, and then B would be square root 7. Square root 7 times square root 7 is 7. So then you have x squared minus 7. D, x minus square root 5 times x plus square root 5. Draw our box. X minus square root 5, x plus square root 5, we have x squared plus x square root 5 minus x square root 5, and then minus the square root of 25, which is negative 5. So we have x squared minus 5. That's our simplified expression. We have 2 more examples. For example 4, we will rationalize the denominators. We have 3 all over x minus square root 7. To rationalize a denominator, we'll multiply by the conjugate of that denominator. So it'll be x plus square root 7, x plus square root 7. Now the conjugate's not always just changing the sign if it's higher degrees, like a cube root or a cube or anything like that. Basically, 2 conjugates together will make a sum or difference of that power. Since we're dealing with squares here, it'll be a difference of squares. So, from C, we already know that the denominator will be x squared minus 7. We'll distribute the 3 into each of those to get 3x plus 3 square root 7. When you rationalize a denominator, it's okay to have those irrational numbers in the numerator. You just don't need to have those in the denominator. In general, they want just natural numbers in the denominator if at all possible. F, 2 all over x plus the square root of 5. The conjugate of x plus square root of 5 is x minus square root of 5. And we know from example 4D that the denominator will be x squared minus 5. Distribute the 2, 2x minus 2 square root of 5. So that is your rationalized denominator. So we have 2x minus 2 square root of 5 all over x squared minus 5.